Hussain, इससे पहले आप start करें. Dr. Hussain, please proceed with the presentation today.
Okay, ma'am. Bismillahirrahmanirrahim. Quote of the day. Rasulullah sallallahu alaihi wasallam said, "The greatest jihad is to battle your own soul to fight the evil within yourself." Assalamu alaikum, everyone. I am Dr. Hussain Mahmood. Today, I am presenting on uh, non-parametric test Kruskal-Wallis test under kind supervision of my professor, Dr. Sarah Afzal. Learning outlines. Today we will learn about non-parametric tests and their types, definition of Kruskal-Wallis test, hypothesis and assumptions, formula of Kruskal-Wallis test, procedure, examples and recent advances about Kruskal-Wallis test. Learning objective. At the end of this presentation, participant will be able to describe the Kruskal-Wallis test, its correct uses, assumptions, and overall procedure. Non-parametric tests. Parametric tests are statistical tests for population parameters such as means, variance, and proportions and involve assumptions about the population from which the samples were selected. One assumption is that these populations are normally distributed, but what if the population in a particular hypothesis testing situation is not normally distributed? Statisticians have developed a branch of statistics known as non-parametric statistics or distribution-free statistics to use when the population from which the samples are selected is not normally distributed. Non-parametric statistics can also be used to test hypotheses that don't involve specific population parameters such as mu, sigma, and or p. They are used to test the hypothesis and about population parameters when the assumption about normality cannot be met. Non-parametric tests and statistics can be used in place of their parametric counterparts when the assumptions of the normally cannot be met. The parametric test, pair t-test, the assumption used non-parametric tests, Wilcoxon sign rank test. Uh, in unpaired t-test, Mann-Whitney U-test, and one-way ANOVA Kruskal-Wallis H-test, and Pearson coefficient, Superman's coefficients. Advantages. They can be used to test population parameters when the variable is not normally distributed. They can be used when the data are nominal or ordinal. They can be used to test hypotheses that don't involve population parameters. In some cases, the assumptions, the computations are easier than those for the parametric counterparts. They are easy to understand. There are fewer assumptions that have to be met, and they are easier to verify. Disadvantages. They are less sensitive than their parametric counterpart when the assumptions of the parametric method are met. Therefore, larger differences are needed before the null hypothesis can be rejected. They tend to use less information than the parametric test. For example, the sign test requires the researchers to determine only whether the data values are above or below the median, not how much above or below the median each value is. They are less efficient than their parametric counterpart when the assumptions of the parametric method are met. That is, larger sample size are needed to overcome the loss of information. For example, the non-parametric sign test is about 60% as the efficient as its parametric counterpart, the z-test, such as sample size of 100 is needed for use of sign test, compared with a sample size of 60 for use of the z-test to obtain the same result. What is Kruskal-Wallis test? Analysis of variance use the F test for the compare of mean of three or more population. The assumption of for the ANOVA tests are that the population are normally distributed and that the population variance are equal when the assumptions cannot be met. The non-parametric Kruskal-Wallis, sometimes called the H test, can be used to compare three or more means. It is sometimes called the one-way ANOVA on ranks on the ranks of the data values are used in the test rather than the actual data points. The test determine whether the median of two or more groups are different. Like most statistical tests, you calculate a test statistics and compare it to a distribution cutoff points. The test statistic used is the test is called H statistic. The hypotheses for the test are null hypothesis H naught. Null hypothesis assume that the sample groups are from identical population. H1 is alternate hypothesis. Alternate hypothesis assume that at least one of the sample group come from different population than others. The Kruskal-Wallis test tell you if there is a significant difference between groups. However, it won't tell you which group are different. For that, you all need to run a post hoc test. Assumption. Assumptions of Kruskal-Wallis test are there are at least three random samples. There should be a ordinal ratio scale or interval scale dependent variable. All groups should have the same shape distribution. One independent variable with three or more level independent groups. The test is more commonly used when you have three or more levels. For two level, consider using the Mann-Whitney U-test instead. Example. First example is you want to find out how test anxiety affect actual test scores. The independent variable test anxiety has three levels: no anxiety, low, medium anxiety, and high anxiety. The dependent variable is the exam score rated from 0 to 100%. Second example, you want to find out how socioeconomic status affect attitude towards sales tax increase. Your independent variable is socioeconomic status with three levels: working, scale, middle class, and wealthy. Working class, middle class, and wealthy. The dependent variables is measured on a 5-point Likert scale from strongly agree to strongly disagree. Formula used in this situation, the distribution can be approximated by the chi-square distribution with k minus 1 degree of freedom, where k is equal to number of group. If the number of observation in each group is 5 or more. This test also uses ranks. In the Kruskal-Wallis test, you consider all of the data value as the group and then rank them. Next, the ranks are separated and the H formula is computed. This formula approximates the variances of the ranks. If the samples are from different population, the sum of the rank will be different and H value will be large. Hence, the null hypothesis will be rejected if the H value is large enough. If the sample are from the same population, the sum of the rank will be approximately the same and H value will be small. Therefore, the null hypothesis will not rejected. The test is always a right tail test. The chi-square table G with degree of freedom k minus 1 should be used for the critical values. Since the test is right-tailed, the null hypothesis will be rejected if the test value is greater than or equal to the critical values. For formula for the Kruskal-Wallis test, the formula is H is equal to 12 over n into n plus 1 into R1 square over N1 plus R2 square over N2, so on, and RK square over NK minus 3 into N plus 1. where R1 is equal to sum of rank of sample 1, N1 is equal to size of sample 1, R2 is equal to sum of rank of sample 2, N2 is equal to size of sample 2, Rk is equal to sum of rank of sample k, Nk is equal to size of sample k, N is equal to N1 plus N2 plus Nk, and k is number of samples. Procedure table. Kruskal-Wallis test procedure is step 1, state the hypothesis and identify the claims. In step 2, find the critical value, use the chi-square table. Table G with degree of freedom equal to k minus 1. K is equal to number of groups. In step 3, compute the test values. Arrange the data from the lowest to highest, rank each value, find the sum of rank of each group, substitute in the formula. The formula is H is equal to 12 over N onto N plus 1, R1 square over N1, R2 square over N2 plus RK square over N, K minus 3 into N plus 1. In step 4, make the decision, and in step 5, summarize the results. Example, hospital infection. A researcher wishes to see if the total number of infections that occur in 3 groups of hospital is the same. The data shows in this table. Table shows group A, group B, and group C different hospital data at alpha is equal to 0.05. Is there enough evidence to reject the claim that the number of infection in the 3 groups of the hospital is the same? State the solution, state the hypothesis, and identify the claim. Null hypothesis, there is no difference in the number of infection in 3 groups of hospital, but alternate hypothesis, there is a difference in the number of infection in the 3 group of hospital. In step 2, find the critical value, use of chi-square table, table G with degree of freedom equal to k minus 1, where k is the number of group. With alpha value of 0.05 and degree of freedom is 3 minus 1 equal to 2, the critical value is 5.991. Compute the test values. In first part, arrange the data from the lowest value to the highest value in rank each other, then find the sum of rank from each group. Substitute the values in the formula, and then we get the result is 5.346. In step 4, make the decision since 5.346 is less than the critical value of 5.991. The decision is not reject the null hypothesis. Summarize the result. There is not enough evidence to reject the claim that there is difference in the number of infection in the groups of hospital, hence the differences are not significant at alpha is 0.05. Now recent advances. Alternate form of the one-way ANOVA F and Kruskal-Wallis test statistics. For each to instruction in the classroom, the one-way analysis of various F statistics is rewritten in the term of pairwise differences in individual sample size, sample mean instead of differences of individual sample mean from the overall sample mean. Likewise, the Kruskal-Wallis statistics may be rewritten in the term of pairwise differences in the individual average rank rather than the differences of individual average rank from the overall average rank. The unbalanced design, it is seen that the contribution to either test statistic from a pair of sample is related to the product of the sample size multiplied by the square of the relevant pairwise differences. Supplementary material of the article are available online. The second is analysis of COVID-19 data using neurosophic Kruskal-Wallis test. Kruskal-Wallis H test from the Bank of Classical Statistics test is well-known non-parametric alternate to a one-way analysis of variances. The test is extremely used to decision-making problem where one has to compare the equal of several means when the observation are exact form. The result is helpless when the data is an interval from has some identity. The interval values data often contain uncertainty and impression and often arise from situations that contain vagueness and ambiguity. In this research, a modified form of Kruskal-Wallis test has been proposed for the identity data, a comprehensive theoretical methodology with the application of implementation of the test has been proposed in the research. The proposed test is applied on the COVID-19 dataset for application purpose. The study results suggested that the proposed modified Kruskal-Wallis test is more suitable in interval value data situation. The application of new neutrophilic Kruskal-Wallis test on the COVID-19 dataset showed that the proposed tests provide more relevant and adequate results. Conclusion: the finding of the results suggested that our proposed modified form of Kruskal-Wallis is appropriate is placed of classical form of the test in the presence of neutrophilic environment. Another article, power comparison of ANOVA and Kruskal-Wallis test when error assumptions are violated. The effect of the violation of normality and homogeneity of various assumption on the power of one-way ANOVA F test is situated in this paper. Simulation experiments were conducted to compare the power of parametric F test with the non-parametric Kruskal-Wallis test in normal, non-normal, equal, unequal variances scenarios and equal, unequal sample group means. Each of these 184 simulation experiments were replicate n equal to 1,000 times and power obtained from both F and Kruskal-Wallis test. The Shapirovics test for the normality and Bartlett and Levine test for the homogeneity of the variances are conducted in each experiment. Result shows that the power of Kruskal-Wallis test outperformed those of the F test in the 92 non-parametric cases. Although power of F test is higher than those of Kruskal-Wallis test in 85 out of 92 experiments under the normality assumptions. These differences in all the cases in the study are not significant using both T and sign test. Based on these results, this study favors the Kruskal-Wallis test as a more robust test or safe use rather than the F test, specifically when the distribution assumption of the data sets are doubted. Now it's time for MCQs. A public health researcher wants to compare statistical level related to a 5-point Likert scale among participants visiting 3 different hospitals. The data is not normally distributed. Which test should be they used? NOVA, student t-test, Mann-Whitney U-test, Kruskal-Wallis test, chi-square test.
D. Kruskal-Wallis.
D.
Yes, it's the Kruskal-Wallis test. You applied the Kruskal-Wallis test to compare the effect of 3 drugs on blood pressure and found H is equal to 9.3 with degree of freedom equal to 2. The critical chi-square value of 5% significant is 5.99. What is your decision? Fail to reject hypothesis, null hypothesis, accept null hypothesis, reject null hypothesis, not enough data, use a t-test.
B.
C.
Reject
C.
null hypothesis.
It's C, reject null hypothesis. In a study comparing um, median pain scores, ordinal scale among 4 treatment groups, which of the following condition justifies the use of Kruskal-Wallis test? Pain score are normally distributed, groups are related, independent sample with similar distribution shape, 2 groups only, homogeneity of variance required.
B.
C.
Yes, it's C. Independent sample with similar distribution shape. You're doing research for an article on the waterfall on our planet. You want to make a statement about the height of waterfall on 3 continents. 3 random samples of waterfall height in feet are shown. What will be the corresponding parametric test? Z-test, dependent t-test, independent t-test, ANOVA, and Pearson coefficient.
ANOVA.
D.
Yes, it's D,
B.
ANOVA.
ANOVA.
You are doing research for an article on the waterfall on our planet. You want to make a statement about the height of waterfall or 3 continents. Their random sample of waterfall height in feet is shown for the significance of level for a significance level 0.05 and critical value 5.991. Compute H value. Anyone? This is solution. We put the value in this. We put the value in formula, and then we get the value 0.01. The answer is B, 0.01. The Kruskal-Wallis test is used when you have at least ordinal scale dependent variable and 1 independent variable with 3 or more level. For 2 or more level, we consider using which test? Mann-Whitney U test, Feynman test, ANOVA, significant sign test, and H test.
A.
Mann-Whitney.
Yes, it's A, Mann-Whitney test. Our researcher tests 3 different brands of breakfast drinks to see how many milli-equivalents potassium per quarts each contain. The data obtained is shown at at alpha is 0.05 and critical value 5.99. One will be the null hypothesis is rejected. H value smaller than critical value, H value greater than critical value, H value equal to critical value, H value equal to 0, and H value is equal to 1.
B.
B.
H value greater than critical
Greater
value.
than.
Yes, it's B. H value is greater than critical value. Which test is used to determine if a relationship exists between race, white, black, Asian, and satisfaction with the economy on the scale 1 to 0, where the 1 is extremely unhappy, and 10 is extremely happy. Satisfaction is not normally distribution and n equal to 47. One-way ANOVA Kruskal-Wallis test, Mann-Whitney U test, independent sample Z test, and chi-square test.
B.
B. B.
It's C, Mann-Whitney U test.
Mann-Whitney.
3 random brands of coffee are railed for test on a scale of 1 to 10. 6% are asked to rate each brand so that there is a total of 18 observation. The appropriate test to determine if 3 brand tests equally good is one-way analysis of variance, B Spearman rank differences, C is Wilcoxon rank sum test, D is Kruskal-Wallis test, and E is sign test.
D.
Yes, it's D, Kruskal-Wallis test. A researcher want to know whether are not. Three drugs have different effect on knee pain. So the recruit 30 individuals who experience similar knee pain and randomly split them into three groups to receive their drugs, one, drug 2, and drug 3. The following is an example of Kruskal-Wallis test, which is a right tail test, left tail test, two tail test, no tail test, and multiple tail test.
A.
10,
Yes, it's A,
B.
right tail test. This is key over our MCQs. This is our YouTube channel. Thank you.
Thank you very much, Dr. Sen. This